Hi, my name is Isaiah Sashiru Okpevi. I'm a master student of cybersecurity, National College of Ireland. Supervisor Dr. Ross Spellman um, is monitoring my research work. Um, Presenting on detecting fraudulent transaction and network intrusion by utilizing an improved machine learning-based model. Here, introduction to intrusion detection system. Today, we live in the era where the use of network, the use of internet is on the rise. It's a very integral part of our day-to-day activities. People involved in the field of education, business, entertainment, social media make use of this. And as much as users are enveloped by the use of the internet, we see the probability of vulnerability increases. And this is a hallmark or a gateway for several attacks to be perpetrated by threat actors. Any action that compromises the availability, confidentiality, and integrity of a system is termed as an attack. There are major classes of attack: denial of service attack, probe, we have user to root, and we have root to local. So many researchers have done um, several work on network security because it's a serious challenge. A way to stop this attack is by implementation of intrusion detection system, which can also be classified into two: host-based IDS and network-based IDS. Attacks are usually in form of patterns or signatures, and all these are entered into a database. An application or an example of such database is the antivirus that we have today. It stores like relational sets of patterns. Um, when we have a system that has pattern, what we do is we compare such pattern with whatever data is received into the network. By this, we require less computational resources. The disadvantage is that we can only have the present day attack, but attacks like low proof attack, 0 days attack, and different unclear and obfuscated attacks cannot be detected, by the IDS. So by means of updating, when we unravel this pattern, it is also time consuming, to enter this pattern into our database. Based on what researchers have done and um, going with the scope of our work, we'll be looking at the present state of intrusion detection system, um, current approaches that are being used to thwart network attacks. The state currently of IDS is the use of anomaly detection. So modern attacks have been considered to have been registered in a data set, and we are going to adopt our projects, to further detect and prevent fraudulent attack using all forms of pattern, signatory-based machine learning approach. Other research that have been carried out made use of the support vector machine with blend of clustering method, which has proved to be effective. That's an achieve some accuracy of 86%, and some achieve accuracy of 98.6%. With these results, we can say that it's a trustworthy one and it can be used in real life scenario. However, all these patterns work alongside with linear generic programming, which today may not be accurate. So we are trying to improve on the model. Our objective will be bounded around our research question, which says, how can we prevent against and detect fraudulent attacks and network intrusion efficiently using a state-of-the-art technology via network signatures? This leads us to focus our research on machine learning as our core algorithm for understanding and unraveling these network transaction patterns. By so doing, we can recognize and detect these patterns subsequently. I need to bring to your notice that other data sets, have been used over time. But the reason I'm not making use of these previous data sets is because those data sets does not show low proof attack, does not show the nature of day attack. The KDD 99, KDD CUP 99, and NLSK datasets do not have all the number of attack vector that UNSW possess. UNSW MB15 datasets has fuser analysis, backdoor, denial of service, exploit, reconnaissance, shellcode, worms, to mention a few. So by getting these data sets will require a high system configuration. My system is using i7, Core i7 with a RAM of 16 gig and a storage space of 1 terabyte. This will do. Yeah, our model will be fine-tuned. Model predictions will be evaluated using the validation data set and the actual test data sets to check for our model accuracy. So our model accuracy will be based on our F1 score, our precision, recall, and AUC value. Yeah, feature engineering. This is a form of data preprocessing. So what's happening here is that we are bringing all features of data sets into a range. We're using maximum and minimum scalar, and this is an algorithm that is imported from skitlearn machine learning library. It's going to scale all our data into 0 and 1. All we are trying to do is such that we can fine-tune with the selected features. Machine learning models are trained. We are fine-tuning so that our model can work fine. We'll be using different base model such as XGBoost as for our final prediction. Yeah, after every training and fine-tuning, we notice that XGBoost is identified as the best model. It's an extreme gradient boosting algorithm, which compared to other boosting techniques, let me say it's just an upgrade of a regular gradient boosting. It uses different hyperparameters, which can include learning rates, maximum depth, and it uses grid search algorithm. The full walkthrough will be given via the YouTube link. We'll continue the full implementation process on the next page, next link. Thank you.